All right, so going back to the beginning of this unit, what a rational expression is well, let's call it an algebraic fraction. It's a fraction in which the numerator and denominator are not simply numbers, they are usually polynomials, and to be more specific, something is not really a rational expression unless there is a variable in the denominator. That's what makes it happen. It turns out that the difference between what we did on Thursday, which is simplifying a single rational expression, and what you learned on Friday, which is multiplying more than one rational expression, the difference is not even worth talking about. Because when you multiply rational expressions, what happens is you put them together into a single rational expression that you need to simplify. To simplify a rational expression, you basically can cancel factors that are in the numerator and denominator. So, if you do all of the heavy lifting and you take a rational expression and factor it, and it doesn't matter what the factors are, you've got A, B, C, D, E, and on the bottom you have A, D, E, F. First of all, why do I know that all of those letters that I've written are actually factors? The answer is they are in brackets. The A is in brackets in the numerator, multiplied by everything else. I want to highlight that, multiplied by everything else. Just because you put brackets around something doesn't make it a factor, okay? If I have, for example, x plus 2, can I put that x in brackets? Yes. Does that mean x is a factor? No, because it's not x in brackets multiplied by everything else. So bottom line is, if you do all of the work to factor things and that's what you get, it doesn't matter what a is. A could be x plus 8, but you have an x plus 8 and an x plus 8. They're gone. You have a d and a d, an e and an e. And then you're done. Whatever you have left, b, c over f is your answer. And then the last point about non-permissible values, they are found prior to canceling. So even though we got rid of the a, d, and e, a is still not allowed to be 0, which I get it. It seems weird that I'm telling you a can't be 0, and there isn't even an a there anymore. But it's a fact. You need to do that. And similarly, D, E, and F all cannot be 0 as well. So we'll talk about multiplying in a bit, but basically with all of these problems, you cancel factors that are common to the numerator and denominator. So let's just start there. Does anybody have any questions from page 317 that you would like me to go over? Ashira? 2b? All right. So what is the operation and quantity that must be applied to both the numerator and denominator of the first expression to get the numerator and denominator of the second expression? So we have 2 over x plus 4, and remember, we can rewrite fractions, and a rational expression is a fraction, in many different disguises. I can multiply the top and the bottom of a fraction by 3 if I wanted to. I can multiply the top and the bottom of a fraction by x if I want to. But in order for you to see what's happening to this, what's happening to the numerator and what's happening to the denominator, you need to factor the expression that it turns into. So I have a common factor of 2 in the numerator up here. I can factor that 2 out and be left with x minus 4. And on the bottom, x squared minus 16 is a difference of squares. It factors into x plus 4, x minus 4. So, I could just answer it, but sorry about that. We have this 2 that's in the numerator of the original expression, and we also have a 2 that's in the numerator of the new expression. So the 2 is, it's tagging along for the ride. We have the x plus 4 in the numerator, in the denominator of both expressions before and after. So the only thing that's different is there's an additional x minus 4 as a factor, which means the answer to this question is you're multiplying both the numerator and the denominator by x minus 4. Is that okay? By the way, if we were going in the other direction, you would say you're dividing the numerator and denominator by x minus 4. Any other questions from page 317, this section? Go ahead, Gabrielle. D? Okay. So we have 1 over y minus 1, and it's turning into, well, I'm just going to write it in factored form. I can factor a y out of the numerator and be left with y plus 1. And in the denominator, I can factor a y out and be left with y squared minus 1. But I'm not done yet, because y squared minus 1 is a difference of squares. And if you're like me, and maybe you are, as I was factoring this, I was thinking there's something wrong with this question. But then I realized I can factor further. So we need to just stay on the path here and see what happens. This now becomes y times y plus 1 over y times y plus 1, y minus 1. And I'm going to do the same thing I did with the previous question that we just did, which was B. I'm going to highlight what we had to begin with. And we had a y minus 1 to begin with, and we also had a factor of 1 in the numerator. But we still have a factor of 1 in the numerator. I can put a 1 as a factor whenever I want. So I have 2 extra pieces that have been layered onto things. I have a y that I've multiplied the top and the bottom by, and I have a y minus 1, pardon me, a y plus 1 that I've multiplied the top and the bottom by. So what we've done is we've multiplied the top and the bottom by y times y plus 1. And that's the answer to the question. Now, maybe in the back of your textbook, it says we've multiplied the top and the bottom by y squared minus y. Sorry, I keep flipping back and forth here. My apologies. We've multiplied the top and the bottom by y times y plus 1. In the back, it might say you're multiplying the top and the bottom by y squared plus y. But that's just found by multiplying that y through. And I would question why you would even do that. Why not just leave it like this? Have I answered your question? Okay. Any other questions before we take a look at the next set of problems that were assigned Friday? All right. So when we're taking a look at multiplying rational expressions, you'll notice that the steps I've got up here are the same as the steps I just talked about. And I'm going to illustrate this by going to a specific example. We might as well do, it doesn't matter. Let's do E here. I'm going to use E as an example of what to do. Let me rewrite this. We have d squared plus 3d plus 2 over 2 times d plus 2. 2d plus 2, and we're multiplying by, and I'm just going to squeak a multiplication symbol right here. We're multiplying by 2d plus 6 over d squared plus 5d plus 6. I'll just double check everything. I think that looks okay. So to begin with here, I just want to get this out of the way. You cannot at this level. If you start doing what I'm about to do and write on the board, I don't know what to say. I've totally failed you as a teacher if you believe that you could do something like this. You're lacking the fundamental understanding of what it means to cancel things. You cancel things because you're dividing the numerator and the denominator by that thing, and the only way you can cancel by division is if it's a factor. Okay, so we factor everything. what I've got on the top of the first rational expression is a very basic quadratic trinomial. Factors into d plus 2 and d plus 1 because 2 times 1 is 2. 2 times 2 plus 1 is 3. The denominator has a common factor of 2, and we're left with d plus 1, and I'm going to actually put that 2 in brackets. Now, when you multiply fractions, and I'm not saying, well, let me write down an example. If I ask you to multiply those two fractions, what you're taught originally, everybody, is that what you do is you multiply. By originally, I mean maybe back in grade 6. I don't know when you first learned about multiplying fractions. You're taught that what you do is you multiply across the top and you multiply across the bottom. Now, 2 points. You don't actually take 4 times 21. Not at this level. Don't do that. But the point is, that's the rule for multiplication. But what we've gone from is 2 fractions being multiplied to a single fraction. So when I do this and I look up top here at what's in brown, I have 2 rational expressions being multiplied, but when I multiply across the top, I'm going to continue factoring here. Now what I have is a single rational expression. So we're back at what we learned on Thursday. This isn't even multiplying anymore, it's simplifying. So I can cancel things. I can cancel a d plus 3 here and here, a d plus 2 here and here, a d plus 1 here and here. I had no idea this was going to happen, but it does. Everything cancels, just by coincidence. So we're left with 1. By the way, the non-permissible values would be -1, -2, and -3. Don't read too much into the fact that it all cancels, but if it does all cancel, then you're left with 1. The bottom line is, I could have left these as separate rational expressions, and you're allowed to cancel a factor on any numerator with an identical factor on any denominator. Capiche? That's it. That was Friday's lesson, really. Put things together as a single rational expression and cancel. Does anybody have any of these you would like me to go over? Jay? 2C? All right, so we have 4z minus 25. We're looking up here. And, you know, maybe to drive my point home, Jay, what we actually have is a single rational expression, right? And of course, these are multiplied. And I really hope you appreciate that there's no difference between this and what we did on Thursday. But we need to factor everything. So you should recognize 4z squared minus 25 as a difference of squares. Because 25 is a perfect square of 5, 4z squared is a perfect square of 2z. The most difficult one to factor is the denominator of the first expression, and I'll get back to that. We also have z minus 4, that's already done, and we also have a 2 that I can factor out of the 4z plus 10 and have 2z plus 5. So here's a little tip. I see a z minus 4 in the numerator over here. And I'm looking now at factoring this. Okay? I notice that 20 has a factor of 4, and all I'm getting at is that it's conceivable that maybe it's z and 2z and 4 and 5. Like maybe it is. And I'm going to try that first because I see there's a z minus 4 over here on the top. So maybe that's what's about to happen. And I can check it out now, and if I do, I'm right. That's a Z, not a 27. So are you okay with the factoring? Okay, if I were to look at the non-permissible values right now, Z is not equal to 5 over 2. And this is something I haven't reviewed since last week. But what you're doing there is you're saying that this is not allowed to be 0. And you're solving that non-equation to get this statement. I hope you see that if we do the same thing here, you're going to get negative 5 halves. So let's just be economical with what we write. And I don't think I really need to explain why Z is not equal to 4. And now we can do the canceling. I have a 2Z plus 5. I have a Z minus 4. I have a 2Z minus 5. Boy, not much is surviving some of these today. What we're left with is 1 on the top. So if I ever say, what are we left with on the top? It's not nothing. It's the number 1. And we have 2 on the bottom. And this seems absolutely wild that we're going to say this expression is equal to 1/2, but Z is not allowed to be these numbers because Z isn't even there. Doesn't matter. You have to write it. When we get to Math 30, there are going to be reasons algebraically, mathematically, why we need to have those non-permissible values. Any other questions before we get started today?